India has a lot of potential. Youth in this country has a lot of potential. Sad story is this potential energy never gets converted into kinetic energy. And that is what we are here for. We are going to stake fire in your belly and see if you can take up this challenge and start programming all these different devices which are so exciting and so wonderful to program.
Thank you, Kanetkar sir. ये थोड़ा केबल इसका ये नीचे से अगर खींचे तो ओके. Hello. Can all of you hear me at the back? Okay. I just lost power to my laptop. So, otherwise when I am talking, suddenly you will see my computer hibernating. I don't want that to happen. कहीं से केबल पुल हुआ है. एडजस्ट कर रहे हैं. हाँ, अभी आ गया. ठीक है. Sorry for the delay. So as Kanetkar sir was rightly telling you, the evolution is something that always fascinates us. But there is one aspect of evolution that I think we have to be very careful about. I am sure in your early childhood, all of you have studied how ape became a man, or of course a girl or a woman. Problem is, we can't start by being apes today in computing. You can't say that I am going to begin computing where it was 20 years back and then I am going to live that 20 years of evolution and then arrive at today. It just doesn't work like that. I could start my evolution 10 years back. Somebody else who was studying at that time also could start his evolution there. But today we have arrived where we are. So as students today, you have to begin at the current level. You can't begin in the past. If you are learning embedded systems, you can't build 8-bit microprocessors because we have 16-bit microprocessors already, right? So you have to study the latest things and know how to program with today's technologies. Now music is something that has fascinated mankind all along, even when there was no digital technology around. But today, I see every day I go for a morning walk or jog, I see in the park that everybody is listening to music. So music is very soothing, agreed. But when I see that, I see all of them carrying either their iPods or mobile phones and having their headphones listening to music, I always wonder what it must take to build a music player of your own. So the day when I asked this program to myself, I realized that I don't have a simple answer to that question. Looking at the way technology has progressed, there has to be a simpler version than what I studied some 10 years back when I was in college, because at that time I had to write a 500-line program to play music. So if I had to do the same thing today, it would be really a shame. So what is it that we have to do? What is it that it takes to build something like this today? So let's see how that works. So I'm going to first show you a demonstration and I'm going to show you the program, the entire source code of that, which is written in C by the way, thereafter. So that was the program, right? So it works. The test of a program is it has to work. Otherwise, if I show you the entire program and then it doesn't work, there is no point, right? So now let's see what it takes to write such a program. These are embedded devices, right? All of you might recognize that by the sheer look of these devices. Embedded means the program is running on a non-conventional platform and their developed for that specific purpose. The only purpose of these devices is to do that and that activity alone, which is play music. Irrespective of whether it is made by Apple as an iPod or any other music players, all of them are single purpose devices. Now we have much better device called as PC or laptop that we all possess. The biggest advantage is that it is not tied to a single purpose. You are able to create programs of your choice, load them, see them in action, and that's why as a development device, PC or laptop continues to be the hot choice even today. So let's first see the technologies that are involved in creating such a music player. If you want, you can write down the program and what I'm talking about, because you are not going to find it in any books. So the technology that we are going to use is called as component object model. The short form for that is COM. So when I say COM, it's not .com, I'm talking about component object model. For music playback, it's definitely understood that you have to have ability to render the music file to the hardware that is present, which is the audio card which is present in your laptops or mobile phones or any other device which is capable of playing music, which is the sound card. And then that is connected to the speakers, and that's how the music plays. But that is the lowest level. When we write a program, we don't begin at the lowest level, we begin at the right level. Windows operating system allows you to write a program once and ensure that program runs on all kinds of devices. If I write a music player program, I should be able to run it on my laptop, which is an IBM laptop. If I copy the program to your PC, which is also running Windows by the way, but it has a completely different set of hardware, the program still works. How does it work? That is because Windows operating system provides what is called as abstraction. Abstraction means that because of the device drivers and the OS, the same instructions that I write on one PC are able to run and execute successfully on another system. That's why I don't have to write the program in assembly language. I don't have to understand even which company's audio card is present in my laptop. I can just write the program using the services that are provided by Windows operating system. Now these services are nothing but functions, just like printf, scanf, fread, fopen, fwrite. These are also functions that you use to program the hardware. Now these functions are collectively called as API. API stands for Application Programmers Interface. Very good. By the way, most of you are MCA students here? Okay, so generally I make it a point to ask that first, so you know what API stands for. So naturally Windows has a very rich set of API, not just for multimedia applications but other applications as well. Now if there was Windows API, where is this technology COM and why is it needed even? The reason is Windows API on last count has more than 6,000 functions. 6,000 functions, some of the functions taking 9 to 12 different parameters. For any programmer to make sense of all of this, to write one complete application starts to become quite difficult. And as I told you, you have to write the program today. You can't go to the era of Windows 3.11. In Windows 3.11, there were just 100 API functions. So you could pretty much read all the functions, their documentation, go through a book and figure out, okay, this is my universe and I'm going to write all my applications around those 100 functions. 6,000 functions makes it quite challenging, plus structures and other things that are there associated with any API. When Microsoft realized this, that this was getting difficult, they developed a technology called as COM. COM, as I just mentioned earlier, is a very important technology because it allows you to write programs at a higher level. It allows you to write programs in any language of your choice. So if you are using COM, you can write the programs in C. You can write your applications in C++. You can write them in .NET languages, which is C# and VB.NET. So the choice is always good, because if you know of a programming language, use that. If you know C, use C. If you know C#, use C#. So naturally the programmer's choice is always very important. This is something that you have to know. You have to know, because unless you know what the choices are, you will not be able to make the correct choices. So this is the foundation of our program, which is going to play that music that I just showed you. So in this set of COM components that are available on Windows operating system, there are hundreds of COM components that are available. The COM component that I am going to use for playing back the MP3, by the way, MP3, as I don't have to tell you what MP3 is it? right? MP3 is a popular format for storing the music. It is popular because the files are not as large as, for example, AVI files, plus the quality of the sound is not compromised. So if you listen to MP3 music, the quality is quite good. So you are quite happy with the format like that. So the program that I have written plays MP3 songs as well as AVI songs. So it's not limited to just one kind of songs. Any other music format is also okay. That is supported on Windows, will work fine. But that is our primary choice today. The name of the component that I am going to use, every COM component also has a name. Functions have names, so COM components also have name. Is called as Filter Graph Manager, sometimes also abbreviated as FGM. By the way, acronyms or short forms are there just to confuse you. They just make things sound little divine than they are. They are just words. So let's begin by understanding what COM components do and why are they relevant. As I told you, Windows operating system today has thousands of API functions. So it becomes challenging to understand what are the related functions, and if I have to write an application, which related functions are where. I can't go through a book. If such a book is to be printed, there was a book written by Jeffrey Richter on Windows API, and last count of pages that I have is 1400. So it becomes little difficult to browse through 1400 pages. Even if you go online, you can search, but at the same time functions are there and you have to find which functions are useful to me. COM components make that so much easier. What they do is they allow you to group data, which means structure, information related like the file that you are going to play, the format of the file, the codecs and so on, and the set of operations that are associated with those parameters or inputs, which are the functions, into groups. Now these groups of functions are called as interfaces. Okay. The advantage here is that I already know if I have to do multimedia application, I know that my COM component is Filter Graph Manager. Now within Filter Graph Manager there are certain interfaces. Within single component there are interfaces. So that is interface 1. Functions 1, 2 and 3 belong to interface 1. Function 4, 5 and 6 let's say belong to interface 2. So this is just a scheme that I am just describing. In reality the functions will have some names and then of course we'll have to understand the parameters. But I already know the important set of functions that are going to be relevant to me. This technique is called as encapsulation. Encapsulation because all the things which are relevant are captured together. Those of you who have studied C++ or C# know that object-oriented programming is all about encapsulation in the first level. Of course, there are other things that we do in object-oriented programming. But this is language independent. Remember, I am going to write my program in C, not even C++. So this is something that works even in C. How do I identify the components? That is another question that comes to mind. Functions have name. Components also have name, but in Windows operating system, other than the name, the components have to be identified by what is known as CLS ID. Okay, CLS ID is nothing but a number. It's a large number which is defined in some header file. You have to know which header file that is, and from there the corresponding hash defined would be available to you, and you use that. Every component has an identifier associated with it. Class identifier is for component. And for interface, there is something called as interface identifier. So CID and IID. So that is all. It doesn't take more knowledge than that to begin writing your first COM application or COM based application. So let's see the actual program structure and then I'll show you the code. In software, of course, it is very tempting to start typing the program. But remember, we are not typists, we are programmers. So when you are a programmer, it is first important to plan out what your program is going to do, right? The program structure, what are the relevant pieces that you need in building that program, and then actually write the program. So in this program, I am going to make use of the component called as Filter Graph Manager, as I mentioned earlier. There is some data which is associated with the music playback. In this case, the file which I propose to play on the audio card of my PC or laptop. Then there are certain functions that I am going to use within the interfaces. To actually start the music playback, I am going to use the function run. To render it on the audio card, I am going to say render. And as you saw, there was a message on the console window indicating that I am waiting for the playback to finish. Why? Because once the music playback occurs, it takes for the music file to play to completion normally. So I can't exit the program. I have to wait until the music playback has finished. So for that, there is a function called as wait for completion. For doing all of that, these functions are not all by themselves, unlike the traditional APIs, they are grouped in interfaces. So there are three interfaces that I am planning to use here. Media event, media control and graph builder are the names of those interfaces. All part of this single COM component. That is the basic premise of this program. I'll just pause here for a minute in case you are writing down. It's fine. So finally, let's see the program. Proof is in the pudding, right? So this is the pudding. At the top of my file, it's going to be a single file that I'm going to write this program in. Very simple program actually. Since COM can be accessed through multiple languages, when I use COM in C, at the top of my file, before even I include my first header file, I have to define a macro called as C obj macros. That is the name of the hash define. That makes the COM accessible through C. Otherwise, COM is by default accessible using C++. My program is written in C. Now, where exactly are the class identifiers and interface identifiers defined? There is a file. Name of the file is dshow.h. D stands here for direct show. Direct show is a name of the technology that is used for multimedia applications on Windows. Even gaming, as later on in this day, we are going to show you some games. So, those also rely on the DirectX family of technologies. Of course, main, right? How can there be a program without main? Now, when we write programs these days on Windows, we write programs using a character data type called as wide character data type. Wide character is important because all the Windows APIs today accept file names in even non-English languages. If you have seen the Hindi edition of Windows, you probably have noticed this already. You can create the folder names and even file names in Hindi, Marathi, Gujarati, whichever language is supported, right? English characters could be fitted in 1 byte. 256 character for printable, non-printable characters, everything, it was sufficient. But naturally, you know many Indian languages cannot be held within 1 byte character type. So all the characters have been assigned in Unicode, which is the system used to represent non-English languages, 2 bytes. So these 2 byte characters are represented by a type called as wchar_t. W stands for wide. So I'm representing that by a variable f name, which is the name of the file. So if there is a file name song.mp3, it will be stored here. Now why did I put a L there? L means it's a long string, which means every character, even though this is English name, tomorrow if I want to store a non-English name, it should fit. So I'm saying that for English, the second byte would be wasted. So I'm going to store all the characters in only the lower byte of that 2 character space. So that is okay. I mean, that much of memory is wasted, but it's okay. Before I can start using COM in my applications, I have to call a API function called as CO initialize. CO means COM initialize. Initialize the component object model framework. Only then I can start accessing COM within my applications. I need to be able to load the filter graph manager COM component in the memory of my program. So for that I have to identify, do we have it? So, well, anyway, so we are going to use the function CO create instance. First parameter is the address of this CLS ID filter graph, which is the identifier which is defined in dshow.h. So it's coming from that header file. So we are telling that we want to load this filter graph manager, and there are other parameters which tell what kind of load that is to be. It is loaded in the current address space of the process. So CLS ID in proc tells it that. Within that COM component, there is an interface called as iGraphBuilder. I need to know the address of that interface. So I'm collecting that in the last parameter, which is PGB, pGraphBuilder, and that's the call. So this creates or loads the filter graph manager component in memory. Now I have collected the address of that in PGB, so I must declare that. So I have declared a variable of type iGraphBuilder, right? This is also a structure which is defined in the direct show header file. To be able to control the playback of music, I am going to use a couple of other interfaces. I already showed you the structure of the program. I said I am going to use a media control and media event interface. So control is for controlling the actions, play, pause, forward, reverse, those kinds of things. And event is something that allows me to know about problems during the playback. For example, if the music file is truncated, it will tell me about that. If I am playing live music from the internet, then if there is a problem with the internet connection, it will let me know about that. Those kinds of things are communicated via these interfaces like media event. So these are the variables which accommodate those values. I'll show you where exactly they are used, but I have to make the program work and compile, so I must define these variables. So let's say that the address of this filter graph manager component in memory is address 400, could be any address. So I hold that address in my variable PGB. Previous slide. Pointer. Okay. Yes. A co-create instance is a function that is used to load the COM component in memory. So it takes set of parameters. Whenever there is a 0, you see that that is a default parameter. So if you don't want to change the default behavior, you use that value of 0. COM components can be used in multi-threaded applications. So this parameter in proc says that this is not a multi-threaded application, it's a single threaded application, and we want to load it in the current process address context, and this is the interface identifier which we want to use to access other components. As I explain rest of the program, then it will become clear. And the address of that component is going to get loaded in this variable, which is uninitialized to start with. But when this function co-create instance returns, these are all hash defined. This is a hash defined, this is a hash defined, this is a hash defined. But this is where the address gets collected. So that is where we have to pass the address of our variable. These are not variables. These are hash defines in the header file dshow.h. So wherever that component's address is there in memory, which it will be available here in the PGB. Now, to obtain the address of other interfaces, I have to use a function which is specific to that particular interface. So for the graph builder interface, there is a function iGraphBuilder_query interface. This is the way COM technology works. First you load the component and then you load the interfaces that you are interested in. Because a single component might have multiple interfaces. You don't really want all the interfaces, you want specific interfaces. So the query interface says that in this component, this is the interface, load me the address in this variable PMC. Now interestingly, the addresses of all these are same. So what PGB contains and what PMC contains is exactly the same, but you cannot assume it. The reason why you cannot assume is, in certain cases, depending on the system where the Windows operating system is loaded, certain components may not be available for that hardware. So if you assume that they always are present, your program may not work. So you have to always obtain the address using the query interface method. So that was the first interface that I queried, media control. Second interface that I am going to query is IID_media event. The address of that I am going to obtain in PME, P media event. That's it. I am done with the interfaces and the loading of the component. Now I am going to actually begin loading the file onto the audio card and playing the music. So the first method I am going to call is going to be on the interface iGraphBuilder. Name of the method is render file underscore, because every method has to be prefixed with the underscore within that interface. PGB is the pointer to that interface interface, and file name, if you remember in the beginning of the program I had declared that as an array of wide characters contains the name of the file, and last parameter is the default value. To actually start the music file playback, I am going to use the control whose address I am obtaining in PMC. So when I say run, the media control interface takes that file which is loaded in the filter graph manager and actually renders it on the audio card. When you heard the song, after this call was made, the song playback actually started. So it is now running. How long will it run? for the length of the music file. So whichever is the length of the music file, it will actually continue to run until that music file is terminated. Now problem is my program is not going to wait, because remember my program is just playing the music file, but where is it playing? It is actually playing on the hardware. So my program is going to continue. My program is not going to wait here. It transfers the music file into the hardware and that's it. It comes back, it returns. So to ensure that my program doesn't terminate until that playback is over, I use the media event interface, and in media event interface there is a function called as wait for completion. Using this interface pointer that I had obtained in PME, for how long do I wait? I can give a fixed timeout. I can say wait for 1 minute, and it will only wait for 1 minute and then it will come out. Or I can say infinite. Infinite is, as you know, in programming of course nothing can be infinite, but something which is very large value. So when I say infinite, I am going to use this infinite from the header file, because I didn't define this constant, but this is a macro defined in the header file again. So wait forever, that is what it means. And this event is at the end of the playback. If there is an error, it will be indicated in this event variable. So the address of that event variable I am going to pass as the last parameter. In the end, what I loaded in memory I have to release, just like when I create application where I use malloc. For every memory that you have dynamically assigned, you have to call free. So similarly, every interface object that I have loaded, I have to call release. So first I called media control underscore release, I media control underscore release. PMC is the parameter to that. Next, media event, which is this interface media event underscore release. Parameter to that going to be PME, and then the graph builder interface pointer. So from the graph builder component, I have used 3 interfaces. I have loaded all the interfaces. Now I'm going to release all the interfaces. Finally, I'm going to tell Windows OS that COM application that I had written is now terminating. There is no need to use COM services. So for CO initialize was the first call, CO uninitialize would be the last call in my program. And that's the end of the story. So today, if you have to write a multimedia application, this is pretty much what you have to do. Any music player that you see, including Windows Media Player, doesn't use anything more fancy than this. In fact, it uses something similar. Now I have shown you only run functionality, but of course there must be other. You are able to seek to a given location, right? When you actually play MP3 song, if you want to listen somewhere from the middle, you can always use the GUI to do that. Of course, I haven't built that GUI, because if I build that, there will be nothing left for you, right? So let's say that that's your assignment. This is a music player. Irrespective of how it looks like, isn't this a music player? Yes, because I see some familiar signs there, right? It might be called as Warcraft, but there is nothing to do with war here. So what you have to do is you have to start with a program like this and build a graphical user interface, because the end users don't like command line applications. They are not going to type music player, name of the file. They want something more fancy in terms of interface. But the point I was trying to make is that teaching that was not my objective here. Showing you what it takes to harness the power of today's PCs, today's Windows operating system features is what I wanted to illustrate here. So what do you think, sir?
Yeah, that's wonderful. In fact, from the program you could, I think, make out that the program was full of pointers. So unless and until you have a good grasp over pointers, COM technology is going to be difficult for you. So I thought that why don't we brush up some of the concepts that you might already be knowing about pointers, such that we are on a better platform to be able to program COM.